In this video, we're going to look at how to handle a situation in which we're repeating a single experiment. And in our case, the experiment is going to be rolling a die 5 times, and we're interested in the probability of getting exactly 3 4s when you do that. So I like to separate this problem into sort of 5 different rolls. 1, 2, 3, 4, 5. So there's your 5 rolls, and we're interested in getting 3 4s. So let's just write down one way that could happen. You could get a 4 on the first roll, you could get a 4 on the second, and you can get a 4 on the third. Right? There's your 3 4s. And then the next 2 rolls, well, all we care about is that they're not 4s, right? Because in this situation, we're interested in the probability of getting exactly 3 4s. So I want to use the not symbol. That's that little tilde there. Not a 4 and not a 4. So that's one possible outcome, right? You take a die, you roll it 5 times. You could get 4, 4, 4, not a 4, not a 4. That's one way we could get 3 4s. Now let's talk about the probabilities associated with that. And so this is why I like to break it up into sort of 5 different rolls, because it allows me to use the multiplication principle of probability. So the probability of getting a 4 on the first roll, just consider that first roll for now, is 1/6, right? There's 6 numbers on a fair die, so there's a 1/6 probability. All right, and so then when I roll the second die, there's also a 1/6 probability of getting that 4, and the operation binding these is multiplication here. So for the first 3 rolls, it's getting the 3 4s. It's a 6 times a 6 times a 6, and then on the 4th and the 5th roll, we can get anything except a 4. And so since there's 5 numbers that are not 4, then the probability of getting that non-4 is a 5/6. And then the probability of getting not a 4 again is again 5/6. I don't know why I made that fraction different. So in total, when you multiply these out, you essentially have a 6th times 6 times a 6. That's a 6 to the 3rd. Times 5/6 squared. Now, at this point, a lot of students think that we're done. They think we're done because they say, well, look, we just sort of looked at the situation, and these are the probabilities that it would be. But they fail to recognize that we have to add in all the possible ways that you can get 3 4s, exactly 3 4s, when you roll it 5 times. So what I mean is you've got to actually, there we just did one way, but another way you could get 3 4s is like this. You could get, for instance, a 4, and then a non-4 on the third roll, and then a 4, and then a non-4, right? You could do that, and in this case, you'd get a 6th for that first roll times a 6 probability for the second times 5/6 times 1/6 times 5/6. And again, when you multiply these all out, you get, there's 3 1/6 here. So it's a 6 cubed. Times 5/6 squared, right? So here's one way we could get it, and here's another. So like we would add those together, and now I'd have to keep going. I'd have to keep figuring out, etc. I would have to keep figuring out all the ways I can get 3 4s and exactly 3 4s when I roll a die 5 times. Now, to make this analogy a little bit more clear before we go on, take a simpler example. Like consider the experiment. So I'll just do this up here. Consider the experiment just flipping a coin twice. And then if I ask you, what's the probability of getting a head and a tail? All right, what's the probability of getting a head and a tail? We could play the same game. We could go, okay, well, there's 2 slots here. And I could get a head and then a tail, that's one way I could get this. I could get a head and a tail, and that has a probability of 1/2 of getting a head on the first flip, times the probability of 1/2 of getting the tail on the second flip. So this gives you 1/4, right? But we know that that's not the only way to get a head and a tail, right? There's another way to get a head and a tail, and that is you get your tail on the first flip and your head on the second flip. And again, that's a probability of 1/2 times a probability of 1/2 gives you 1/4. And we add those to give you basically 2 1/4, which is 1/2. If you actually list out the outcomes, which is possible in this coin flip problem, but not in the die problem, realistically, unless you have tons of free time on your hands. I mean, when you flip to a coin twice, you can get a head-head, you can get a head-tail, you can get a tail-head, or you can get a tail-tail. And we can see that out of those 4 outcomes, 2 of them yield a head and a tail. So all that is confirmed in this flip a coin experiment. So the point is, we've got to figure out, and so there are 2 ways, right? There are 2 ways you can get a head and a tail. So we multiplied this 1/4 probability that we got up here. Essentially, we just multiplied it by 2. What we got to do is figure out how many ways we can get 3 4s and 2 non-4s in 5 flips. 5 rolls, I should say. So what does that amount to doing? It amounts to figuring out how many ways we can put 3 4s in these 5 slots where the other 2 slots are not 4s. So we've already done it up here twice, but another possibility is 4 here at the end and 4 in the middle, not a 4, not a 4. That's another possibility. We got to count how many ways that arrangement the arrangement of 3 4s and 2 non-4s can happen. And to refer to a previous video, that's no different than at me asking how many ways can you arrange 3 C's, or how many words can you come up with 3 C's and 2 R's? Right? Imagine the C's being your 4s and the R's being your non-4s. The number of ways to arrange those is 5 factorial divided by 3 factorial, 2 factorial. Or, another way to see that is that's just 5 choose 3, by definition. If you want to take the choose approach, just think about, out of the 5 slots, we have to choose 3 of them to be where the 4s are going. So this is how many times I would have to keep writing out the 5 slots and adding up those probabilities. So my answer is going to be 5 choose 3 times 1/6 to the 3, 5/6 squared. Since this is how many times I would have to add up those. And if you take out the calculator and punch it in, you end up getting, just going to make this a little smaller. You take out the calculator, do our 5 choose 3. Five choose 3. That's 10. So I get 10, and then a 1/6. So a 10 times a 1/6 cubed, 5/6 squared, ends up giving you 0.032. So there's a 0.032 probability of getting exactly 3 4s when you roll a die 5 times.